In this video, we're going to talk about the binomial distribution. So we have a very specific type of experiment that's going to be really useful to us, and that's called a binomial experiment. There are three main characteristics of the experiment. First, there's a fixed number of trials, meaning it's repeated 5 times. We typically use n to represent the number of trials. There are two possible outcomes, success or failure. They may not be called success or failure. For instance, when you flip a coin, getting heads or tails, that could be success or failure, right? Heads would be success, failure could be tails, but you might be calling it heads or tails. It doesn't have to be called success or failure. But in some cases, we may want to rewrite something so that it's thought of in that scenario as a success versus a failure. So, like when you roll a die, there are 6 outcomes. But let's say I'm interested that you get only a 2. So, the success would be rolling a 2, and failure would be rolling everything else. So, it's somehow setting up an experiment so that it has what we're considering just 2 types of outcomes. Okay, and then the third thing is that the trials need to be independent. That's very important because we need to be able to repeat the conditions over and over again to see what the outcomes are. And we use P to be the probability of success, and Q will mean a failure. Okay, so here's what's really nice about these types of experiments. There's a nice, easy way to calculate the mean and the standard deviation. So to find the mean for a probability experiment, it will be mu equals the number of trials times the probability of success. Now, to standard deviation, we need the variance. The variance is the standard deviation squared. So, in a binomial probability distribution, the variance, which is little sigma squared, is n times p deviation is the square root of n times p times q. So these are the two we will focus on. The variance isn't as important, but it is something that has been mentioned, and I wanted to kind of mention it again just so that you're familiar with it. It is the standard deviation squared. Okay, so in the late 1600s, we had a experimenter, Jacob Bernoulli, who created such an experiment, a binomial experiment, and his is where n equals 1. So when we're having one trial, that's a Bernoulli trial. Just as a note for anybody who might see that phrasing used. Okay, so let's do an example and kind of fit all of this information into an actual problem. Approximately 70% of statistics students do their homework in time to be collected and graded. Each student does homework independently. That's important for it to be binomial. In a statistics class of 50 students, what is the probability that at least 40 will do their homework on time? Students are selected randomly. So before we get into that question, they want us to kind of address, is it a binomial experiment? So first, to be a binomial experiment, it has to have a fixed number of trials. In this case, we're going to treat the trials like students. So yes, we have 50 students in this class. There's a fixed number. So each student is quote unquote a trial. Okay. Two possible outcomes. So in this scenario, we're talking about they do their homework in time to be collected and graded. So yes, there's 2 outcomes, and that would be uh, homework for grading and not for grading. Okay. And then they are independent because they told us that. So, yes, it is independent. We're treating each student as if they're not going to affect each other, whether or not they do their homework in time for being graded. Okay, so this would count as a binomial experiment. It has the 3 qualifications, 2 and 3. Okay, so if we are interested in the number of students who do their homework on time, how would we define X? So they want us to literally define what X is in this problem. So X would be, and I'll say it a lot better than I did in the last statement up there. So X is the number of statistics students. I'll just say stats students who do their homework on time. And we're defining on time as meaning in time to be graded. So they're going to get it counted for their benefit to their grade. So what values does X take on? So in this class of 50 students, is it possible that no one does their homework? Yeah, it's possible, but it's not likely. So that's a possible value X could take on. Or maybe one student does their homework, or two students, or three students, and so forth. In other words, it could be all the way up to 50 students. All 50 of them do their homework. That's also not as likely, okay? But it's possible. So that would be the values that X would take on. And I'll just put the dot, dot, dot because I don't want to list all of the numbers up to 50. Okay, so what is a failure? In this case, in words, a failure would be somebody who doesn't complete their homework on time for grading. Who doesn't complete their homework on time. And again, we're counting on time as so that they can receive a grade. Okay, so what is Q? And you might recall up at the top, Q is the probability of failure. So if the probability of success is 70%, then the probability of failure would be 30%. And notice that they kind of wrote it out as P plus Q equals 1 because they're complements of each other. P being success and Q being a failure means that they are going to add up to 1. They're complements of each other. Okay, so write the question, what is the probability that at least 40 students will do their homework? And they want us to actually write this into symbols. So this is what you would see on the homework. So they would say the probability that our value of X is going to be bigger than or equal to 40. So at least 40. So they could be 41, 42, 43. They could be all the way up to 50, but minimally they have to start at 40. So 40 of those 50 students doing their homework. That's going to be how they notate this. Now we'll talk about in the next video how you would actually calculate this.